Okay, so question number 46 on page 678 says 2-point charges of 8 microcoulombs and negative 5 microcoulombs respectively are placed 10 centimeters apart in a vacuum. So this is my 8 microcoulombs, charge number 1, and this one is my minus 5 microcoulombs, charge number 2, and it says they're placed 10 centimeters. So this distance is 10 centimeters apart in a vacuum. At what location along the line between their centers will the electric potential difference be 0? So this time it's not asking for 2 spots like it was in example 3. It's just asking for the one between their centers. It's always going to be closer to the one that's smaller in magnitude. So this piece will be R1. This piece will be R2, and it'll be 10 centimeters minus R1. And so they're looking for the point where V1 plus V2 will equal 0. In other words, where KQ1 over R1 will equal negative, because you have to take it across, KQ2 over R2. So we have 2 unknowns here. The K's will cancel. We have 2 unknowns, R1 and R2, but we can substitute in for R2 so that it's 10 centimeters minus R1. Okay, and so now you're going to cross multiply. I'm just going to bring it up here. So it'll become Q1 brackets 10 centimeters minus R1 will equal negative Q2 times R1. Multiply through by Q1, so Q1 times 10 centimeters minus Q1 times R1 will equal negative Q2 R1. We're solving for R1, so I'd bring this negative Q2 over. So Q2 R1 minus Q1 R1 will equal negative, oh, I should have taken it the other way. I have way too many negative signs now. Negative Q1 times 10 centimeters, pull out the R, Q2 minus Q1 equals negative Q1 times 10 centimeters. And so R1 is equal to negative Q1 times 10 centimeters over Q2 minus Q1. Fill in your numbers. So 1 was 8, so negative 8 microcoulombs times 10 centimeters. And on the bottom, negative 5 microcoulombs did I mess up a negative sign? No. Minus 8 microcoulombs. So on the top, you're going to get negative 80 centimeter microcoulombs. On the bottom, negative 13 microcoulombs. And when you divide that out, you should get 6.1538 centimeters. And that would be towards number 2. And then to get your R2, just take it away from 10 centimeters, and you should get 3.8462 centimeters, and that would be toward number 1. Now, if they had asked for the second spot, it would be over here somewhere because 5 is smaller than 8. And so R1 would be this whole thing, maybe, and then R2 would be R1 minus 10 centimeters. Or you could call this R2 and R1 R2 plus 10 centimeters. But they did not ask for that, so we'll leave that. There's another question that does. So we'll get back to it. Number 47. Number 47 says, what is the potential difference at point P situated between the charges of 9 microcoulombs and negative 2 microcoulombs as shown in the diagram? So this guy is my 9 microcoulombs. Over here is my negative 2 microcoulombs. And the point P is about here. And it tells us this is 4 centimeters and this is 2 centimeters. So you need to find, if I call this number 1, you need to find V1 and V2, and then it wants the total. So then you would add them together. So V1 will equal KQ1 over R1. 9 times 10 to the 9th Newton meters squared per coulomb squared. times 9 times 10 to the negative 6 coulombs over 4, oops, that was centimeters, so over 0.04 meters. 36 divided, or 81 divided by 4 should be 2.025 times 10 to the 6 volts. That's for V1. V2 will be KQ2 over R2. So 9 times 10 to the 9th Newton meters squared per coulomb squared times negative 2 to the negative 6 coulombs divided by 0.02 meters. And you will get a V2 of, oh, the 2's cancel, so that should be about 9 times 10 to the 6 volts. Okay, so we have our V1. We have our V2. The question wants to know what's the V total. So V total is just equal to V1 plus V2. So V total is equal to 2.025 times 10 to the 6 volts plus, and did I lose a negative? Yeah, this is a negative. Plus a negative 9 times 10 that's 5. Sorry. This is a 5 here. 9 times 10 to the 5 volts. So when you do this, really, then you end up taking away the 9 from the 20. So you'll get 1.125 times 10 to the 6 volts. Right? I was just doing the math in my head there in case you were wondering where I was getting 9 and 20, because this is like 20 to the 5th. All right? Number 49. We did 48 the last set. So number 49 says, and we'll run out of time probably before we finish this, but we have a rectangle. A is up here in the corner, 2 microcoulombs. B is down here, negative 4 microcoulombs. C is over here, negative 8 microcoulombs. And then there's no charge at this point D. Okay, the distances the sides are all 6 centimeters. It's a square. And so there's a diagonal here. Oops. And we could find that diagonal, right? 6 squared times 6 squared. So 3672. So the square root is 72 centimeters. Which would be 8 point something, and then you 8.486 centimeters. But now the question wants to know what's the total potential difference at the midpoint of the diagonal. So you need to divide this by 2 to find the different R's. So it should be 4.243 centimeters. We'll have to change that to meters when we go to use it. It was just easier for me to do it in my head in centimeters. Okay, so all of the R's are going to be half the length of the diagonal. And it wants the total potential here, which means we need to find VA, VB, and VC. And then because potentials are scalar, we can just add them together. So VA will be KQA over R. So 9 times 10 to the 9th Newton meters squared per coulomb squared. 2 to the negative 6 coulombs. And R is 0.04243 meters. And you will get a VA of 4.24264 volts. Then do B, KQB over R. 9 times 10 to the 9th Newton meters squared per coulomb squared. 4 times 10 to the negative 6 coulombs. It's a negative. The R is the same, 0.4243 meters. And you get a VB of negative 8 for